Well students, let us continue with exercise 10.4 of chapter 10, circles. This is question number 2, wherein you have circle with center O, with chords AB and CD intersecting at E, and also you have chord AB equal to chord CD. You need to prove that AE is equal to DE and BE is equal to CE. So what we are going to do now is what we've been doing since so far. You're going to draw perpendiculars from O to AB and CD. So let this perpendicular from O to CD be M and O to AB be N, and I will join the points O to E. So now if you notice, in these two tiny triangles out here, ONE and OME, you have right angle triangle out here. So OME is equal to angle ONE. You have the hypotenuse OE as common, and also you will notice that OM is equal to ON. Why is OM is equal to ON? Because you have chords AB and CD equal to each other, and OM and ON are the perpendiculars to these chords. So what do we know about chords that are equal in length? The perpendiculars drawn to them are equal. Therefore, you have OM is equal to ON. Therefore, these two triangles are congruent to each other by the RHS test of congruence. Therefore, you have NE is equal to ME. Let's write this down, then we will continue further. So I'll start with my proof. We'll draw the constructions first. Draw OM perpendicular to CD and ON perpendicular to AB. Join OE. Now, so first let's prove that OM is equal to ON. Now, chord AB is equal to chord CD, and ON and OM are the perpendiculars from the center of the circle to these chords respectively. Therefore, we have, so ON is equal to OM. Let's mark this as statement number 1. Now, in triangle ONE and triangle OME, I have hypotenuse OE is equal to hypotenuse OE. Why? Because it is the common side. So I'll say common. Then I have angle ONE is equal to angle OME is equal to 90 degrees. Right? Because each of these are perpendiculars, and also have ON is equal to OM. I'll say from 1. Therefore, triangle ONE is congruent to triangle OME by the RHS or right angle hypotenuse side test of congruence. Therefore, through corresponding pair of congruent triangles, what do I have? I have NE is equal to ME. Why? Corresponding pair of congruent triangles, or CPCT. Let's mark this as 2. Now, you have AB is equal to CD, this is given. Also, AN will be equal to AM. Why? Through here. See, N and M would be the midpoints because AB is equal to CD, and here we have the perpendicular lengths. What do we know? That the perpendiculars drawn from the center of the circle to the chord bisect the chord. Therefore, N and M would be the midpoints of AB and CD, which is why half of AB is equal to half of CD, and that means AN is equal to DM. So when you add AN is equal to DM to point number 2, you get AN plus NE is equal to DM plus DE, which means AE is equal to DE, which is the first point out here. So let's go ahead and write the proof for this. I'll say now AB is equal to CD. This is given. Therefore, half of AB is equal to half of CD. Therefore, AN is equal to DN. Since perpendiculars drawn from center of circle to the chord bisect the chord. Therefore, you have M is the midpoint of AB and N is the midpoint of AB and M is the midpoint of CD. Right? Let's mark this as 3. So when you add 2 and 3, what do you get? That AE is equal to D. When you add equals to equals, the wholes are equal. Therefore, adding 1 and 2, I get adding 2 and 3, I get NE plus AN is equal to ME plus DN. Right? Therefore, AE is equal to DE. This is Roman number 1, so this is proved. Also, we need to prove that BE is equal to CE. So now let's notice over here, AB is equal to CD. Now AB is equal to CD. When you subtract AE from AB and DE from CD, what do you get? BE and CE. But what do you have? AB is equal to CD and AE is equal to DE. So when you subtract equals from equals, the remainders are equal. So now what we are going to do is subtract. Let's mark this as, or rather we will say AB is equal to CD, this is given, and AE is equal to DE. I will say from Roman number 1. Correct? Therefore, AB minus AE is equal to CD minus DE. So AB minus AE is what? AB minus AE is BE and CD minus DE is CE. Therefore, BE is equal to CE. This is Roman number 2. So with this we have proved both the two sections. This is Roman number 1 out here and this is Roman number 2 out here. So please take a look at the solution of this question. Thank you for watching this video.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.